We've all seen AI spit out some pretty smart-sounding answers, but what happens when a problem isn't just a simple question? What about when it requires, multiple steps of logic? Well, that's really the cutting edge of AI research right now. So let's dive into how AI is actually learning to reason, moving from just giving answers to genuinely solving complex problems. Okay, take a look at this. On the left, a standard language model makes a classic mistake. It just kind of mushes the numbers together and gets the totally wrong answer. But on the right, just by being prompted to show its work, the model reasons it out step by step and nails it. And this right here, this is the core of the challenge. It's about teaching AI not just what the answer is, but how to get there. So for the longest time, the thinking in AI was pretty simple. Bigger is better. Just scale up the models and they'll get smarter. But researchers quickly hit a wall. They found that just making models bigger wasn't enough to close this reasoning gap. Yeah, the models were getting way more fluent, but they weren't getting any more logical. It was clear a totally different approach was needed. And then, in 2022, something really interesting happened. A groundbreaking paper came out, but it wasn't about some massive new model. Instead, it was about a surprisingly simple new way to prompt them. And this one little trick unlocked reasoning abilities that were basically just lying dormant inside the AIs we already had.
It's called chain of thought prompting, or COT for short, and the idea is actually brilliant in its simplicity. Instead of just giving the model a question and an answer, you show it the process, all the little intermediate steps you take to get to the answer. It's really the difference between handing a student the answer key and actually teaching them how to solve the math problem themselves.
And the results? They were absolutely staggering. Check this out. On a really tough math benchmark, a giant palm model went from about an 18% success rate all the way up to 57% just by using chain of thought. But here's the craziest part. That 57% score actually beat a model that was specifically fine-tuned, specially trained for that exact type of problem. A simple prompting trick outperformed a specialized model. That's wild. So chain of thought was a huge leap forward, no doubt about it. But it has this one major weakness. It's Achilles' heel. It follows a single, straight line of reasoning. So if it makes a mistake early on, that error just cascades all the way down. It's like a line of dominoes. If the first one is wrong, the whole thing comes crashing down and you get the wrong answer. So how do you fix that? Well, this brings us to the next big evolution. This is where things get really cool. What if, instead of just following one chain of thought, the model could explore multiple different paths of reasoning all at once and then pick the best one? That's the core idea behind a new model called Marco-o1. To pull this off, it borrows a technique from the world of game-playing AI, like the one that made AlphaGo so famous. It's called Monte Carlo Tree Search. Honestly, the best way to think about it is like a chess grandmaster. They don't just think about their very next move, right? They're thinking several moves ahead, exploring all these branching possibilities. If I do this, my opponent might do that, then I could try this. MCTS lets an AI model do the exact same thing, but for reasoning problems. So here's a little peek under the hood. The problem, the prompt, is like the root of a tree. And every single node is another step in the reasoning process. The model isn't just stuck on one branch. It's branching out everywhere, exploring all sorts of different ideas and potential solutions. It's kind of like it's creating a whole mind map of possibilities to find the very best path to the right answer. Now, this whole process works in a constant loop. First, the model selects what looks like a good path to follow. Then it expands on that path, adding new possible steps. Next, it does a rollout, which basically means it follows that path all the way to a final answer. And then, and this is the important part, it does a backup. It looks at the result, was it good or bad, and it uses that feedback to get smarter for the next loop. All right, so that search capability, that's the first huge piece of the puzzle. But Marco-o1 has another trick up its sleeve, and honestly, this one feels almost human. It adds this layer of self-critique, a way for the model to literally second-guess its own work. And this is the actual prompt they give it. It's not a metaphor. At the very end of its thinking process, the model is given this exact instruction. It's literally the AI's version of pausing for a second and asking itself, hold on, did I get that right? Just think about it. It's exactly like when you finish a tough math problem and you go back over it one last time just to double-check your work, or like a writer proofreading their own essay. This reflection mechanism is like an internal quality check. letting the model catch and fix its own logical mistakes or calculation errors before it's too late. Okay, so we've got this incredible tree search for exploring all the options, and we've got this reflection mechanism to double-check the work. What happens when you put them both together? Well, the results are pretty darn impressive. Let's see it in action. Here's a perfect example. On the left, the normal chain of thought model sees the word restart and gets totally tripped up, ending up with the wrong answer. But the MCTS-powered model on the right, it doesn't get stuck. It explores another possibility. It thinks, what if restart means starting the entire thing over again? And boom, that leads it down the correct path to the right answer. It literally reasoned its way out of a dead end. And it gets even cooler. Turns out the level of detail in the search matters a ton. On the left, a broader search makes a simple calculation error and gets the wrong profit. But on the right, they adjusted the search to be more fine-grained, breaking the problem into tiny mini-steps. By zooming in like that, the model could spot and fix that one specific mistake, leading it to the correct answer. It shows that it's not just that you search, but how you search that really counts. And of course, we've got the numbers to back this all up. On a multilingual math test, an already powerful base model scores a little over 84%. Pretty good. But just by adding the MCTS search method, the accuracy jumps by over 6 percentage points to more than 90%. I mean, that's not a small bump. That is a significant leap. And it really proves this whole search and reflect method works. So this brings us to one last fascinating thought. Let's just step back for a second. We started this journey with AIs making simple, straight-line mistakes, and now we're looking at systems that can explore a huge space of solutions like a chess master and self-correct their own work like a diligent student. The line between mimicking a process and actually understanding it is getting really blurry, isn't it? So we have to ask, are we seeing the first real sparks of genuine artificial reasoning? That's the question this research leaves us with.